Hello everyone, this is Masoud Moosavi and I'm going to talk about the final project of distribution management. It's model of picking up the friends as a capacitated vehicle routing problem. First, I'm going to give you some general information about CVRP model, and also after that I'm going to talk about the model that I have worked on, and after that I'm going through the solution in Python and the experiments on what I have run during this scenario. And at the last step, I'm going to make a conclusion based on what I have reached out. I have worked on an innovative CVRP model in different scenarios and make a comparison between them. And one of the scenarios is a simple TSP model. So I had the chance to make a comparison between the TSP model and also CVRP model. The CVRP model is a kind of VRP model which vehicles has a limitation in terms of the capacity, and they need to pick up and deliver items at the various locations. Uh, as you know, the items have a quantity such as weight or volume, which has a capacity. So the vehicles need to obey the rules of the capacity limitations. And the problem is to pick up and deliver items for the least cost while never exceeding the capacity of the vehicles. And the CVRP model is one of the fundamental problems in the combinatorial optimization with some practical applications in transportation, distribution, and logistics. The aim of CVRP is to find a set of minimum total cost routes for a fleet of capacitated vehicles based at a single depot. So the rules is that each route begins and ends at the depot. Each customer is visited exactly once, and the total demand of each route does not exceed the capacity of the vehicles. In this problem, I just have considered the capacity of each location as one, but you can change the numbers based on the code. It can be changed. And the reason that I did that is to make a comparison between TSP model and CVRP model in the case that just sorry, one vehicle can go around, which is going to be a kind of TSP model. The model is about a group of friends which have been invited to a party, and the party owner decided to rent some cars and pick them up as a guest. And he is looking for minimizing the total cost of transportation, which includes two parts. The fixed cost is the cost of rent of car, and also the variable cost, which is cost of transportation. It's based on the fuel consumption per kilometer. You just need to consider that the cost of driver or operator is included as a part of the fixed cost. And also in continue, you can see that the capacity, the fuel consumption, and rental price of each car is different. And there is no inventory limitations to rent different number of cars. I mean, adjust a specified car. The distance between guest locations and party location are random numbers of x and y, which are between 1 and 150 based on kilometers. Based on the former table, the location of guest and also party has been depicted through Visio. In the next step, the Euclidean distance has been calculated for each of the locations. As you can see, I have considered four different types of vehicles, including Honda Civic, Jeep Wrangler, and Volkswagen van, and Fiat minibus, which each of them have different rental costs, different capacities, and fuel consumptions, and the variable cost is calculated by dividing uh, the fuel consumption by the kilometer, which is 100, and multiply by the cost of fuel in Canada. I just need to mention that the capacity which is mentioned is the net capacity. I mean, the driver is ignored, and this is the total capacity which can be used. And at that time that I start this project, the cost of gas per liter was 1.7 Canadian dollars, but I know that it's different now. I have defined six different scenarios which can meet the total capacity limitation. The six mentioned scenarios are the minimum number of cars that might need in which they meet the demand. It means that the total capacity is equal or greater than 14, which is the total number of guests. Each guest is not able to have a partner, but it can be changed in the other models. And it is important to consider that the last scenario, which is the scenario number 6, has a capacity of 16 persons, which is a kind of TSP model. And at the last of presentation, I'm going to make a comparison between TSP model and CVRP model. And I just need to mention that the model and the codes have been run separately for each of the scenarios. The results in Python code shows the optimal answer for each scenario. It includes the optimal routes, the distance, and the total optimal distance. Scenario number 2 is the best answer of this problem with around 434 Canadian dollars, and the minimum time of transportation is around 4.9 hours by considering the average speed be 70 kilometers per hour. It is the only scenario that all of the capacity have been used. Here is the roadmap of scenario number 2. As you can see, there are three different routes, and two of them has the capacity of 5, and one of them has a capacity of 4. Scenario number 6 as a TSP model had the total cost of 483.6 Canadian dollars, and by considering the speed of 70 kilometers per hour, it takes around 7.5 hours to pick up all of the guests and back to the party. As you can see, here is the roadmap of scenario number 6, which is a TSP model. To sum up, scenario number 2 with 434 Canadian dollars is the lowest cost between these scenarios with 2 Jeep Wranglers and 1 Honda Civic. I have to mention that scenario number 6, which is kind of TSP model, it takes a long time to deliver all of the guests. So this means that it's not reasonable sometimes to just rent a vehicle with large capacity. And this project has taught me how increasingly I can convert my basic ideas like picking up the friends to go to the party to a reasonable model like CVRP. And it's invaluable because I could analyze the possible ways to find the best answer based on what I have learned during this course as an engineer. And I have found also that minimizing the cost is not only object that we might need in the real world challenges, the total time spending, for example, and distance may also play an important role. And thank you all for your attention.